What's the x value?
H.
I don't know what the y value is. This idea right here is why when we talk about vertical lines, a vertical line is always x equals a number. Specifically, for an axis of symmetry, so an axis or line of symmetry, it's a vertical line, and the x value is always equal to what? H. The axis of symmetry, x is always equal to h. Because it has to go through the vertex, and the x value of the vertex is, and for in general, h. So for this one, it would be x equals 3. What are your questions about that idea of the axis of symmetry before we continue? Yes, Aaliyah.
So, like, it says x minus 3, so it always, like, it would be like negative, but it always would be the opposite.
It's always going to be the opposite because it's x minus h. Whoops. It's x minus h. So to get x minus 3, I would need a positive 3. I would point this out also if it was a negative 3. If h was negative 3, when you subtracted negative, what do you get? So to get a positive, you had to have a negative h. Does that make sense? So that's, again, how we see that's the opposite. Okay, concavity. Any guesses?
Concave up.
Why? What's the evidence for that?
Because A is a positive number.
There we go. Now I want you to notice that. Concavity is not 2, right? Concavity is not positive. Concavity is either up or it is down. Because A is positive, the parabola is concave up. Right? Notice that reasoning. That's what you would want to show on assessment. It's concave up because the value of A is positive. Right. Okay, fill out the rest of that table. Once you finish that table, move on to do the next set of slides for the standard form. It's on the back side. Is that 1/2 apart? Is that H? Where's your 1/2?
Okay.
Right there, right? Isn't that the value of A? Remember, it's A times x minus h squared plus k.
So, the value of A.
Okay, talk about it. That's a good question. Talk about it. I'll put the answers up in a second.
Okay. So, the value of A.
Any discussion so far? I think you might need a head so much.
You're good, Dave. I used to do very well. The first those ones.
Oh, that's fine. Move on to standard form. Hey guys, the answers are on the board. Does anybody have any questions?
Never know.
Okay.
I got it.
Excuse me, hey, I need y'all to pause. What are your questions? Alexandria has one. Okay. Anybody know why x equals -1 here? Or have a way to explain that? Lexi?
All I can think is 2 negatives is a positive.
So you're referring to over here, right? Remember, to get x plus 1, right? It was x minus h. So to get x plus 1, h had to be a -1. Were you good with that -1? So remember, the axis of symmetry is just x equals h. So if it's going through -1, it has to be x equals -1. Okay, what other questions do y'all have? Alright? Let's move to standard form.
Like, in, you're going.
And I'll go ahead and tell you, don't make it harder than it has to be. You're only looking at A and C, but start with A and move from there. Don't spend too long on A. So if it was a positive, right? And I have this. This is my equation. If H is a positive one, I'm going to get X minus 1 squared. And that's why we want the inverse, because notice if H is a positive one, I get X minus 1. That's not what happened. Right? I have X plus 1. To get X plus 1, I had to subtract a negative. They're the same, so this is the same thing as what we see here. That should be a negative 5 and a negative 5. It's always the opposite. Notice when X minus 8 is positive. When it's X plus 5 it's negative 5. X plus 5, negative 5. Then, cool, perfect, thank you. Well, it's not, it's just a line, you can say it's just a line. But focus on the questions over here, right?
Do this one first.
When the value is positive versus the value is negative.
And then he's going to, this one is not as visible or easily seen at all.
What's different
So he's going to show
A
you
is
how to
positive
find
and
the X and Y's up and all that. But I would play around with it for a little bit and see similarities between what you just looked at.
Can I say?
I'll say this. You've already come up with an idea. You can move on to the part C if you want to.
Okay.
Wait, the y-axis.
What's going on?
It stays on.
What is that? Oh, you're saying the y-axis. Does it change?
We're on the A value versus
Calculating A.
yes, add some.
I would think more so
Okay, so
in
for A,
relation to,
two different.
what did A represent in our last
The
equation?
top is like,
It could be.
What
Have you looked at slide 10 yet?
manipulate?
if it's negative, then
But it's on slide 10. What am I asking you to look at?
It's a fun word.
But specifically here, when the value of A is positive versus when the value of A is negative.
Yeah,
Go back now.
concavity.
Think about it that
So
way.
A kind of manipulated concavity in the last equation. So play around with A, okay, so what is that? Concave down,
A is
that's negative,
negative
what's
versus when A is positive.
positive. What happens if A is equal to, what happens if it's not positive or negative?
I will say this. The C being super negative right now is making it hard.
Yeah, when A equals 0, what happens?
That'll make it easier to see.
It's a line, it's no
I thought I might
longer
have done
a
this.
parabola. But you said earlier when A is negative, it's going to go down.
No, I did it, I've modified it. I'm always looking to improve.
That's concave, it's positive. So when A is negative, it's concave down, right? And then when it's 0, it's a straight line. So what I'm going to point out here is cross axis, which is cross axis, he does, but
So what part of the
right here,
graph
you see the
shows the same value?
CX plus C.
So the X is lining up.
That means
They
the
will actually
structure
see
does
show up in
way,
the graph.
which leaves us BX plus C,
Anybody
which
else
is the
figure that
form
out?
of a line, right? MX plus B, it's the same thing, just using different
So right now.
So that's why that's when it's equal to 0. But anytime it's not equal to 0, that's what
Right,
gives
so
us a
that's
parabolic shape or like
here C is
or rounded
4.5,
shape.
and what's the y-intercept?
Were you asking something else?
4.5.
No. Did that clarify kind of what you're looking at for A?
How's it going for you?
Yes, that was unsure.
Well,
It was.
I know that,
I'm still a little
Cross.
Okay, with what?
but like
Like, this is just,
I'll give it
Pause for a second. What do you mean by it is the y-axis?
sorry.
It is on the y-axis. What's another word we can use for that?
Up, down.
But what's the point located on the y-axis? I mean, it is a certain distance from 0, but listen to that question again. What is the point located on the y-axis? It's a y something. It's a what? Y-intercept, right? Isn't the y-intercept? Because, and here's the issue. Okay, this is what you want to pay attention to. This whole line right here is the y-axis. You're not talking about the whole y-axis. You're talking about that one point on the y-axis, the y-intercept. Right. What's your c value? 4, right? Where do you see that number 4 on this graph? Right? You keep getting in your head something now. Okay? I will say this. You're making A harder than it has to be. Think about what we've already discussed about an A before. And also, if you look at slide 10, there's some questions there on slide 10 to help you. Don't do B. Like, don't change B. They'll just make your job harder, I promise. Don't necessarily put B to 0. Maybe B of like -4, -2, or something like that. Yeah, just do an integer though. We're going to talk about B later. What is B?
Look at that thing, so at the very top.
It's changing the slope, but only when you let A be 0.
We're saying.
Not necessarily when A is not
What does
0.
that mean?
Does that make sense?
What is the A squared mean?
Go home.
Away, right?
Look at the home button.
And that
Zoom
means
in.
so
Focus there, okay? What did y'all found out about A? What'd you write down? Okay, but when A is positive, what? Concave up. When A is negative? Thank you. Thank you. Thank you. Okay. I know some of us are getting our own heads. Quit doing that, right? It's just focusing on what's a pattern that I see here. And so we're going to talk about A first in which form are we looking at right now? Standard form. And what is the equation for standard form?
X squared plus B plus C.
What's the equation for standard form? Y equals... There you go. Okay, so I've got that standard form there. What is A controlling? What part of the parabola? What's the up or down? The concavity, right? Concavity. So when is it concave up? When what is positive? When A is positive.
A is positive.
Okay, when A is positive, the parabola is concave up. So when A is negative,
The parabola is concave down.
sounds familiar, doesn't it?
It's like the last time.
Oh, it's like just like with vertex form. What about when A gets further from 0? Does it still seem to be vertically stretched? Like it's a little bit skinnier? Okay. When A is closer to 0, does it still seem wider or vertically compressed? Well, we'll talk about that actually, that detail in a second. But yeah, when A, oops, that's still vertex form. When A is closer to 0, is it wider? Vertically compressed, yeah. So I got to point this out. Do y'all? I will say this. Do you need to write all of those details down again?
Yes.
You could. Could you also just say, see the notes for A under vertex
Oh my
form?
gosh, you sure could do that.
Okay. So see notes for A under vertex form. Yes, it could help you rewrite it, but also I do want you to notice that what A is doing hasn't changed. A is still A. It's still controlling the concavity. It's still controlling the vertical stretch and vertical compression, things like that. Okay. So now the mystery. Actually, A is equal to 0. Miss Estel pointed out that I meant to talk about this and I never did. When A is 0, what do you get? A line. Well, all lines are straight. I remember being so bugged by that when I was in high school, and now that I understand why teachers do that, I get it. But all lines are straight, right? It's a line, okay? So let's talk about why. Right now, A is 0. What is 0 times x squared plus bx plus c? That's a 0, isn't it?
Is anything times 0?
So what am I left with?
Bx plus c.
What's that an equation of? That's y equals mx plus b. That's the equation of a line. Right? So when A is 0, you're going to get a line
Why?
every time.
Every single time?
Every single time.
When
If A is 0, your parabola becomes a line, right? You no longer have that quadratic element. You're left with a linear equation. Okay? So that's where that's coming from. Now, I'm going to show you one other quick detail because I think someone in first block said it beautifully. She was talking about how when A was going from positive to negative, it almost seemed like, did she say transported?
Yeah.
She kept talking about how the vertex was just transported to the other side of the graph. Which, I mean, I get it, right? It goes from quadrant, what is that, quadrant 3 over to quadrant 1.
Yes.
And it just feels like it just jumps there, it transports there. So here is why. This is a detail that I know that there's no way we're going to see on our own, so I didn't bring this up, have y'all explore this. But the vertex can be found from standard form. The x value, this is only in standard form, right? So the x value of vertex is x equals negative b divided by 2a. This only works in vertex form, right? You need ax squared plus bx plus c. But the x value of your vertex is negative b divided by 2a. Now I'll go ahead and tell you, I cannot prove why unless we use calculus, and y'all haven't taken calculus yet, so just take my word for it for now. Sorry. So the x value of the vertex is x equals negative b divided by 2a. Okay? So here's why it appears that that vertex or that parabola is just transporting over to the other side. I want you to look, I'm going to make it a nicer a value. Okay? So right now, if I were to look at it, x is equal to, now it's negative b, so negative, or that's the opposite of b. Currently b is a positive 5, right? So what's the opposite of a positive 5? Okay, so I've got negative 5 divided by 2 times a, which is, okay, what's a negative divided by a negative? A positive, right? So the x value of the vertex is 1.25. Does that look to be like the x value of the vertex to you? Positive 1.25? Deja, you see up there at the vertex? The x value of the vertex is 1.25? So that's how we get it, right? Now, if I change a to a positive, sorry you feel this way, okay? In this case, what is my b value? B is still 5, so negative 5 divided by 2 times a positive 1. What's a negative divided by a positive? A negative. And that's going to be negative 2.5. That's why it appears like it jumped to the other side, because we're looking at the division of a negative by a negative or a negative by a positive. You know, we still have like 10 minutes left, right? 9 minutes? We go till 1:40. Oh. Note, if I make b,
Oh,
is it all? Sorry. Yo, that is exactly right. That is 1:32. We get out of here at 1:40. Sometime. For the ACT, that's when it was. Okay, so note right now, okay? See how b is negative right now? So what's the opposite of b? Right? Negative b. So a positive 3 divided by 2 times, no, is it positive 1?
Yeah.
And so that gives me a 1.5. Do I see in the x value of the vertex is 1.5? Yes. But that's why like the b and the a affect where the vertex is. That's the main thing I want you to see about that. The b and the a affect where the vertex is. Alright? The last detail I will point out is this. How in the world do you think we're getting the y value of the vertex? Mackenzie? Oh, you just had your hand there, not trying to raise it. Okay, here's the thing I will point out. We have the x value, right? What can you do with the x and an equation? Plug it in. You can substitute in, right? X is an input. To get 1.75, you're just going to substitute the x value in. And so the vertex would be written this way. negative b divided by 2a. That's the x value of the vertex, right? What notation can I use to show my input substituted in? What notation can I use to show that the input has been substituted in? What's this called? F of x, that's also known as function notation. You can use function notation. I'm going to say f of negative b divided by 2a. All that means is I'm substituting the x value in to get an output. That's what function notation is. I've got the input, negative b divided by 2a, substituting it in to get out whatever the output is. We'll talk more about that moving forward. Don't stress that too much. But we'll use that. I'll use that notation in the future. And again, talk about it some more. So what about C? Is C the y-intercept?
Yes.
Okay. Does anybody want to push on or add on to that language at all?
Yeah.
Is the what? Close. Okay. Say it again.
Why the y value?
Look, that 4, is that 4 alone the y-intercept?
Yes.
You sure?
No.
Because I think the y-intercept is a point. A y-intercept is a point. I need you all to pay attention to that because you will not have 100% accuracy on assessments if you don't pay attention to that. But the y-intercept is a point. And what is the x value always of the y-intercept?
0.
Okay, so the y-intercept would be written as, what's the x value of the y-intercept? 0. What's the y value? Based on the standard form? C. Right? C is the y value of y-intercept for that standard form.
Just for that standard form.
It's only for standard form. You don't have C in any other form.
Okay. Wait.
Think about vertex form. Y equals a times x minus h squared plus k. No C. And if you look at factored form, there is no C. Yeah, you have 4 minutes if you need to get out of here though. Okay, so y value of the y-intercept, that's what C is. What are your questions before we continue from there? Okay, y'all, they can pack because they have to Leah has to help somebody transport and Clay has to, push himself around. Yeah, anyways, so I do want to point this out. I will ask you to do this. Please complete this chart. It's 8 different things. Complete this chart tonight. We'll come back and talk about it tomorrow to start class. But to end class, I want to look at this. So what's the final form that we're going to look at? Already did vertex form. We've already done standard. Factored form of quadratic. And what's the first thing we're going to look at with factored forms? It says the value of A. Any guesses? Right, anybody guess?
Same
thing still?
No.
You don't think it's going to be the same, Bree? Let's check. So, I am moving to the factored form part. Here it is. When A is positive, the parabola is currently what?
Stretching.
It's concave up. As it gets further away, is it still being vertically stretched? Yes, okay. When A becomes negative,
Concave down.
it's still concave down. As the value gets further from 0, is it being stretched?
Yeah.
So what would we want to say under value of A for that last section? See the notes for A, for A under vertex form. That A has not changed. There's a reason why we use A throughout. Notice how I told Clay and I was mentioning, do we use C anywhere else? No, because C is C. A is used throughout because it's the same thing. A is defining the concavity, A is vertically stretching and compressing. What are your questions at this point? Okay, y'all have 2 minutes. I would go ahead and try to do that chart so that you don't have to do it for homework. Huh? Talk about it in the group. It's okay if you get it wrong. We'll talk about it tomorrow, okay? Yeah. We're active enough in the whole class discussion for sure. You did? Yeah. In your small group. Enough for 425. Did Zany check out?
Mr. Kenny, I just feel like every time I talk in person, you never hear me.
Huh?
I just feel like every time I talk in person, you never hear me.
I heard you multiple times today. I called on you. How you involved in the whole class discussion?
He always does. Like when you actually want to involve.
I only have 2 ears. There's 25 of y'all. Cry me a river.
What about Ocean?
Yeah, cry me an ocean. I don't care. I'm going to do my best to help you. I'm going to try and make it as much as possible. But Chelsea, did I give you credit for lots of ideas? All right. Did I hear you talk? I did.
Marlon, I listen to your music.
Have a great rest of your day. I'll see you all tomorrow. What's up, Nathan?
We're back to that.
Say that one more time.
We're back to the plate.
Yeah, we need some of this every now and then.
Mr. King,
Good afternoon, Nathan.
I didn't get the memo that you got for 2 days.
I told y'all that last week, dude.
Wait, he said about 2 days?
Yes.
It's gonna be on Monday, and you won't be here Tuesday.
I'm sorry that you don't listen.
I mean,
Good afternoon, Jerry.
Yeah.
Good afternoon.